Section 3.2, Probability and Odds. In this section, we will be introduced to the concept of probability and then also to the concept of odds. They are not the same thing. They are related. As you can see in our 3.2 notes, we have a definition of probability. It says the probability of an event is the likelihood of the occurrence of a particular event. We can either describe that as a fraction, a decimal, or a percentage. It will always be between 0 and 1, or as a percentage between 0% and 100%. You can think of the definition of probability in two different ways here. One of them being the number of elements in the event that we are trying to find the probability of over the number of elements in the sample space. Another way to talk about the probability of a certain event is the number of favorable outcomes over the total number of outcomes. What we mean by that, by favorable, is out of all the total outcomes, how many of them match what we are talking about in event E. There is a different definition when we get to odds. We will, of course, come back and talk about that a little bit more once we hit that, but we're going to do our first few examples about probability. After class today, Bob plans to flip a coin 3 times. List the elements in the sample space. In other words, what could happen? For example, you could get 3 heads in a row. That's one thing that could show up in the sample space. You could get a head and then a tail and then a head. That's another thing that could show up in our sample space. Let's list all of the different things that could happen. That makes up what we call the sample space. One thing that's useful sometimes in a problem like this is to do what we call a tree diagram. Here's a tree diagram for this example. When Bob flips the first coin, he's either going to end up with a head or a tail. So that first column represents what is going to happen the first time Bob flips that coin. And then the next column is going to represent the second flip of the coin. And so what we're going to do is we're going to branch off head, tail, like this, head, tail. So the second column represents the second flip. In other words, at this point, maybe he got a head on the first flip and also a head on the second flip. Or maybe he got a head on the first flip and then a tail on the second flip. Or maybe a tail on the first and a head on the second, or a tail on both. Now we need to do 3 coin flips, so we need the third column. So we're just simply going to branch off head, tail off of each of these things. You notice I now have 8 right there. That means there's going to be 8 elements in my sample space. So the sample space is actually the set of all possible outcomes. So we are going to use set notation when we write out the sample space. And all we're going to do is take each of these 8 things and just follow backwards and see where it came from. So this first one I'm going to write down is head, head, head. That's one thing that could happen. If you toss a coin 3 times, they might all become head. Look at the second one here and go backwards and see where it came from. That's head, head, tail. That's another thing that could happen if you flip a coin 3 times. You might get head on the first two and tail on the third. Look at the next one. Here's the third one. Go backwards. Follow it. Head, tail, head. Look at the fourth one. Head, tail, tail. And then we come down to the fifth one. That started here. Tail, head, head. Tail, head, tail. Tail, tail, head. And then finally, the last one is tail, tail, tail. And those are the 8 things that could happen if Bob flips a coin 3 times. There are 8 things, 8 elements in my sample space. It shouldn't be a surprise that we got 8 elements in the sample space. You might remember the counting principle said, if you're going to do something like a 3-stage experiment, figure out how many ways each stage could turn out. In other words, the first time you flip a coin, there are 2 possible outcomes, head or tail. And then the second time you flip the coin, there are also 2 possible outcomes. And the third time you flip the coin, there are 2 possible outcomes. And the counting principle said to multiply those, and that's not a surprise that I have 8 elements in my sample space. Now we get into the idea of probability. Compute the probability that exactly 2 of the flips turned out heads. Okay, so here's the notation. P for probability, exactly 2 heads. So the way this works, your denominator is always going to be like the total amount of things, the number of elements in my sample space. There are 8 possible things that could happen. We just wrote all of them down right there. There are 8 possible things that could happen if you flip a coin 3 times. But in the numerator, we have to write down how many of those 8 meet the qualifications that we're talking about. How many of those 8 have exactly 2 heads? So you just got to go find them. There's one right there that has exactly 2 heads in it. Here's another one right here that has exactly 2 heads in it. And here's one right here that has exactly 2 heads. So I believe there are 3 out of the 8 that have exactly 2 heads. It's head, head, tail, head, tail, head, tail, head, head. Those are the only 3 out of the 8 that have exactly 2 heads. If you are going to give an answer as a fraction, it must be reduced, and that is reduced. You could also give your answer as a decimal if you would like. On your calculator, I would do 3 divided by 8, and that should turn it into a decimal answer. 0.375 is what my calculator says. You could also give your answer as a percentage. And to do that, you would take the decimal answer and move the decimal point 2 times to the right. If I were to move that decimal 2 times to the right, it would end up after the 7. And my answer would look like this. So any of those 3 answers are acceptable. You don't necessarily have to give all 3. You are welcome to if you want to. Sometimes I will, sometimes I won't. Sometimes the direction, though, requests a particular one of those 3, then of course you would follow that. But usually you can just give any of those 3. If you are going to give a fraction answer, you need to make sure it's reduced or simplified. Most of your calculators will reduce or simplify for you. If you're not sure how to do that, you should Google, how do I do fractions on my calculator? Or how do I reduce a fraction on my calculator? And of course, you would enter the type of calculator that you have. You would enter the brand and the model of the calculator that you're talking about. That's something, of course, you can also ask me about separately. How do I use my calculator to deal with fractions? But you should be able to figure that out on your own also. I could show you a couple of the more popular ones. Maybe I'll do that in a minute. Let's go ahead and do this next question. Compute the probability that at least two are heads. For the last problem said exactly two. Now it says at least two. Well, if I flip a coin 3 times, there's still 8 things that could happen. We just wrote out all 8 of them right there. But now the question is, how many of those 8 have at least 2 heads? It would actually be the same 3 that I just pointed out. Remember, this one had exactly 2 heads. This one had exactly 2 heads, and this one had exactly 2 heads. But at least 2 means 2 or more. So when it says at least 2, we could be talking about 3 also, like this one has at least 2 heads. I know it has 3 heads, but it has at least 2. So when it says at least 2, that means 2 or higher. So there's actually 4 of the 8 that have at least 2 heads, and that is not reduced. You could divide top and bottom by 4, and you'd end up with 1 head. If you took 1 divided by 2 on your calculator, it should tell you a decimal answer of 0.5. If you move that decimal 2 times to the right, you'll have to put a 0 there, but it will become 50%. Give me a minute and let me look up a couple of the more popular scientific calculators that people often have in the class. And we can talk about a little bit about how to deal with fractions on these calculators. So one of the more popular types of calculators that I see people have is a TI-30 something. There's different versions of it. But if you look right here, you see an ABC button. That's your fraction button. So for example, that 4/8, if you wanted your calculator to help you reduce that, you would type in 4, and then ABC, and then 8, and then enter. And it would give you back the reduced version of that fraction. Again, you would type in your numerator, then you would type ABC, then you would type your denominator, and then you would type equals or enter, and it would reduce that fraction for you. Another popular one is this one, which is also in the TI-30 series, but it looks a little different. This one has a button right here that looks like a fraction. It says N over D, that stands for numerator over denominator. So look for that. It's right under the PRB button, right next to the LN button, sort of towards the top, 3rd row. So you would just press that button, and then it would just bring up, I think, a blank fraction, and you can navigate and with these arrows over here, and you just type in the numerator and denominator, then you would go press enter, and it would do the same thing. It would reduce the fraction for you. then another one is a Casio. This is a very popular one. This also has a button that kind of looks like a fraction right there on the far left side. Towards the top left. And so you would push that button and then it would bring up like a blank fraction. You would navigate using these arrows and enter your numerator and denominator and press equals, and it should reduce that fraction for you. Again, if you have a different calculator than one of these three, you can Google, put in the title of your calculator and then put in like, how do I do fractions or how do I reduce fractions on this calculator? And it should tell you, and it should pull up videos even. You can go on YouTube and do that. If you can't figure it out after trying those, you're welcome to ask me, of course. Okay, so getting back to these examples, let's look at the next page. How many ways could a 4-question true-false test be answered? And then list the elements of the sample space. Well, this is similar to something I just did a minute ago. If we are going to make 4 decisions, we can think about how many ways are there to make the first decision, and how many ways are there to make the second decision, and so on. If it's a true-false test, there are 2 ways to answer the first question, those 2 ways being true or false. There would also be 2 ways to answer the second question, 2 ways to answer the third, and then 2 ways to answer the fourth question. Of course, true or false on either. If we multiply these, we get 16. That means there should be 16 ways to fill out the answers on a true-false test. So when I go to list the elements in the sample space, I'm expecting 16 things and 16 elements in my sample space. We had 8 in the last question. Now we're going to have 16. So this tree diagram is going to be a little bit bigger. So I'm going to make a tree diagram. The tree diagram is not my final answer. The tree diagram, it helps me come up with my sample space, but it's not my final answer. So the tree diagram this time, we're going to say true and false. Okay. True, false. That first column represents what might we answer on the first question. The second column, we branch off true, false. That represents what we might answer on the second question. And we branch off again for the third question, true, false on each. It gets a little crowded because I actually have to go one more branch, one more column. So now I'm at 3 questions. We need 4, so I need a 4th column. I need to branch off true, false one more time like this. And it is going to get quite crowded here. We're going to end up with 16 things over here on the far right. We know that because of part A. I'm going to do my best to squeeze these all in. So you should see 16 letters there on the far right. Those are the representing the 16 elements of my sample space if we follow them all backwards. So that's not my final answer, what I have written down there. That's just going to help me write out my sample space right now. So one way, the sample space is a set. One way you could answer the 4 questions is look at the very top thing, come backwards, true, 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 true. You could just say true on all of them. Look at the next one. True, 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 false. You could say true on the first 3 and then false on the last one. Here's the next one. Go backwards. True, true, false, true. And then look at the 4th one. True, true, false, false. and so on. I'm going to go a little faster now. I think you probably understand what I'm doing here. I hope you do. The fifth one, true, false, true, 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 false, true, false, true, false, false, true, true, false, false, false. So I have 8 of them. I think I'm halfway done. I think we're right here now. False, true, true, true. False, true, true, false. False, true, false, true. False, true, false, false. And we're down to these last 4. False, false, true, true. False, false, true, false. False, 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 true. And then finally all false. False, 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 false. Now we have the 16. This is called the sample space. The tree diagram is not your answer. The tree diagram just helps you get your answer. Now I actually have a couple follow-up questions for this one. So I have a part C over here. And part C says, if you picked one of those at random, what is the probability that exactly 2 are true? If you picked one of them at random, what is the probability that exactly 2 are true? So out of those 16 ways, there are 16 ways to do this, right? All 16, we see them all right there. So that's why my denominator is going to be 16 here. But how many of those 16 have the property that has exactly 2 trues in it? That's what we're talking about here. Exactly 2 are true. That one right there has 2 trues, so there's 1. Exactly 2 trues. 2, this one has exactly 2 trues. Actually, let's do this. Let's color code this because I'm going to do another question. But let's go underline the ones that have exactly 2 trues. See, that has 4 trues, that has 3 trues, that has 3 trues. This one has exactly 2 trues. So I'm using red on this one. 3 trues, 2 trues. This one has exactly 2 trues. That one has exactly 2 trues. That one only has 1. That one has 3. That one has exactly 2 trues. So is this one. Only has 1. This one has exactly 2. That has 1. That has 1. That doesn't have any. So I think, if I did this correctly, I think there are 6 out of the 16 have exactly 2 trues. Let's double check that again. 1, 2, 3, 4, 5, 6. Those are the only 6, I believe, that have exactly 2 trues. And so there's a 6 out of 16 chance. Okay. I kind of just talked about how you might do that as a fraction, like reduce that on your calculator. You should, of course, also know how to reduce on your own. Like, I don't think you need a calculator to reduce. I'm assuming you know how to deal with fractions. But I did just sort of show you a few minutes ago how your calculator might help you reduce. Top and bottom would be divisible both by 2, and that would get me to 3/8. So 3/8 is a good acceptable answer. 6 over 16 is not reduced. I think we actually just did 3/8 in the last problem. You might remember if you take 3 divided by 8, that becomes 0.375. If you move the decimal twice to the right, that becomes 37.5%. So any of those 3 would be good answers. If you picked one at random, what's the probability that exactly 3 are true? That's a different question. What's the probability that exactly 3 of them say true? Well, I know the denominator's still 16. There are still 16 things that could happen if you were to answer a 4-question true-false test. We know that because we just did that, and they're right here. All 16 of them are right here. But now let's go see how many of those 16 have the probability that exactly 3 are true, because that's what I'm going to put on top now. I'm going to use a blue pen for this one. Exactly 3 are true. Let's see, that has 4 trues in it. This one has exactly 3 trues. That one has exactly 3 trues right there. There's 2. This one also has exactly 3 trues. That has 2, that has 2, that only has 1. This one has exactly 3 trues right there. 2 trues, 2 trues, 1 true, 2, 1, 1, 0. I think it might be just those 4 out of the 16 that have exactly 3 trues in it. So 4 out of 16 chance, right? If you flip if you answer a 4-question true-false test, there are 16 ways to do it, and 4 of those 16 have exactly 3 trues. If you divide top and bottom by 4, you get 1/4. That is the reduced version. If you go to your calculator and take 1 divided by 4, not using the fraction button, but using the division sign, it should turn it to a decimal. Again, on most of your calculators, that's what would happen. If your calculator is not acting the way I'm saying right now, you need to go figure that out, because you have a, I don't know what kind of calculator every single person has who's watching this. So it's a time where you could go to Google, say, how do I make my fraction into a decimal? And then type in the title of your calculator, and it should tell you, or YouTube should have videos for that. If I move the decimal twice to the right, I get 25%. Any of those 3 answers are good answers. Next question. One die is rolled. What is the probability that it is a 4? One single die. I'm going to show you a picture right now of 2 dice. I know you probably know what dice look like. So here's a picture of 2 dice, 6 sides each, right? So each dice is going to come up either a 1, a 2, a 3, a 4, a 5, or a 6. In this particular problem, though, I'm only talking about 1 die. So die is singular. Dice is plural, because in the next problem, we'll say we're rolling 2 dice. But if I'm only rolling 1 die, there's only 6 things that can happen. If I'm only rolling a single die, it's either going to come up a 1, a 2, a 3, a 4, a 5, or a 6, right? I want to know the probability it comes up a 4. So the probability that that roll will be a 4. Well, my denominator is always the total number of things that could happen, the total number of elements in my sample space. Actually, my sample space would be this set right here. That would be the 6 things that could happen if you roll a single die. And how many of those 6 would be the number 4? Just that one. Only one out of the six meets the requirement of being a 4. Only one of those 6 outcomes is a 4. So there's a 1 out of 6 chance that if you were to roll a single die, it would land on a 4. And that is reduced. If you take 1 divided by 6 on your calculator, it's pretty ugly and long, and we're gonna have to round this one off. I'm gonna try to get us in the habit of rounding to 4 decimal places. 16667 is what I'm gonna put in. And some people say, wait a second, mine doesn't say 7. Mine has a bunch of 6s there. But remember, when we're rounding off, okay, so I know this is hard to see, but on my calculator it says 0.1666, a bunch of 6s and then a 7 at the end. But actually just write that down. My calculator says something like this, just a bunch of 6s and then a 7 at the end. But if I'm rounding to the 4th decimal places, 1, 2, 3, 4, my 4th decimal place is right there. I don't just write 6 just because that's a 6. It matters what the next number is. And so remember, if the next number is 5 or more, then I have to bump up my round off place. I have to increase this and go up to 7. And so I'm doing that because the number after my round off place was 5 or higher. Then you have to bump up your round off place. If this number to the right here was less than 5, I would not do that, and I would have left this a 6. So make sure when you are rounding, you are doing it properly, because you will not get full credit if you are rounding incorrectly. The other thing, when we round, notice I didn't put an equal sign here. It's sort of like a squiggly equal sign. This is an equal sign right here. This is sort of like a squiggly equal sign, and that means approximately equal to. That sort of implies that I rounded off. And so if I turn that one into a percentage, it would look like this. So again, sometimes we kind of just have to round off. I usually will try to go often to 4 places like I just did, but you need to round off correctly. You need to follow the round off rules properly. Next question says 2 dice are rolled. What is the probability that the sum is 4? That means they add up to 4. So remember, I just showed you a picture of 2 dice. When you roll 2 dice, there are actually 36 outcomes. I think we mentioned this recently in a different lecture, in a recent lecture, but there are 36 outcomes, and that is because there's first one of the die is going to land on any of those 6 things, and then the other die is also going to land on any of those 6 things. So there are 36 possible things that could happen when you roll 2 dice. I have a picture. I know we've looked at this before, I think also, but I have a picture here of all 36 of those. And I think you also have access to this. We've seen this picture in our previous lectures. You can also easily just create this or Google. I just Googled roll 2 dice. And then this is one of the pictures that popped up. You could easily, though, just put 1, 2, 3, 4, 5, 6 here, and then look at all the possible different combinations here. But there are 36 things that could happen when you roll 2 dice. How many of those add up to 4? That's the question. That's the question we're trying to do right now. It says roll 2 dice. What's the probability that the sum, that means they added up to 4. Sum is 4. Well, my denominator this time is going to be 36 because we're talking about 2 dice, not 1. But out of those 36, how many of them add up to 4 is what we're trying to figure out. You notice this adds up to 4 right here. See 3 comma 1. That means the first die landed on a 3, the second landed on a 1. That adds up to 4. And I also want you to notice if I sort of go diagonally and up to the right, you're going to catch the other ones that also add up to 4. That's usually how this works. If you find one of them that adds up to a certain thing that you're looking for, just go kind of diagonally and up to the right, and you'll probably find the rest of them also. So 3 plus 1, or 2 plus 2, or 1 plus 3. That's 3 things out of 36. Out of the 36 elements, 3 out of the 36 add up to the number 4. And I'm talking about these 3 right here. And so there's a 3 out of 36 chance that if I were to roll 2 dice, we would expect about 3 out of every 36 times we did that the sum would be 4. I'm not promising you that if you rolled a pair of dice 36 times, I'm not promising you that exactly 3 of the 36 will add up to 4. We're just saying that's the most likely thing to happen. That's what we would predict might happen based on abilities. It's quite possible that you could roll a pair of dice 36 times and they never add up to 4. It's also quite possible, well, this next thing I'm about to say is not super likely, but I guess it is possible that you could roll a pair of dice 36 times and every time they added up to 4. That's not very likely, but I guess it's possible, right? So again, when I say 3 out of 36, I'm not promising that if you did it 36 times, I'm not promising you that 3 of them are going to add up to the number 4. I'm just saying that's what we would expect. That's the most likely thing to happen. If I had to make a bet, that would be my guess or my bet. That is not reduced. If you divide top and bottom by 3, you get 1/12. So 1 out of every 12 times. If you take 1 out of 12 or 1 divided by 12 on your calculator and round off 0.0833, make sure you understand why I'm rounding off that way. This time I did not have to bump up my round off place because the next number was a 3, which is less than 5. Decimal or percent answer would be 8.33%. Two dice are rolled. What is the probability the sum is 9? What's the probability this time they add up to 9? Well, I can already just put a 36 on the bottom. I know that's how many things could possibly happen if I roll 2 dice. But nothing changes on the bottom here from the previous question. It's the numerator that's going to be different probably. We have to now go find how many add up to 9. Out of those 36 things, how many are adding up to 9? Let's go find them. Let's go find all the ones that add up to 9. So you search around and try to find just one, and once you find one, you'll probably kind of find the others by going diagonal and up to the right, like I said. You might notice this adds up to 9 right here, 6 plus 3. So there's one that adds up to 9. And then if you go up to the right, 5 plus 4, 4 plus 5, 3 plus 6. Look at this diagonal right here. There are 4 things, right? There are 4 things that I'm pointing to right now. 1, 2, 3, 4. 6 plus 3, 5 plus 4, 4 plus 5, 3 plus 6. There are 4 out of the 36 that have a sum of 9. So 4 out of 36 is what we're about to say right here. If you divide top and bottom by 4, you get 1/9. If you take 1 divided by 9, you get a bunch of 1s. And so, again, I'm just going to I'm kind of in the practice of going to 4 decimal places, making sure you're rounding off properly. But this is how we would finish this problem off. Again, you don't always have to give all three of these answers. Any one of those are usually okay unless the directions ask for a specific version. Let's do a couple probability questions with cards, like a deck of cards. A card is selected at random from a standard deck of cards. What's the probability it is red? E for probability, red is what we're asking about. If you pick a card, just a random, shuffled deck of cards, and you pick a random one, what's the probability you got a red one? What does a deck of cards look like? I know we've already kind of talked about that also in this class in an earlier lecture, but let me remind you about a deck of cards. A deck of cards has 52 cards. 4 times 13. There are 4 suits, and each suit has 13 cards. So each of these lines has 13 in it, and there's 4 lines, right? So the top line, those are called clubs. There are 13 clubs. There are 13 spades. And those top 2 lines are both black, right? And then these bottom 2 lines are red. There are 13 hearts. And there are 13 diamonds. So cards go from ace, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. That's 13 times 4. So 52 cards in the deck. So don't be surprised when we put 52 in the denominator on these next couple of questions. There are 52 cards in a deck. Out of those 52 cards, how many of them are red? Well, half of them are red, right? Half of them are red, half of them are black. The top 2 rows are black, the bottom 2 rows are red here. 13 hearts, 13 diamonds. 13 plus 13 is 26. These 26 on the bottom 2 rows are the red ones. There's a 26 out of 52 chance if you picked a random card, you would get a red one. And then, of course, the other 26 are black. If you divide top and bottom by 26, you end up with 1/2. Not a surprise that there's a 1 out of 2 chance you would get a red card because half of the cards are red. We've done this earlier today also. That is 0.5 or 50%. Next one's a little bit harder. The next one says, what's the probability that that random card you pick would be a black 8? So again, my denominator is going to be 52. When we're doing probability, your denominator is always the total amount of things that could happen, the total number of things in your sample space. If I were to pick a card out of a deck, there are 52 things that could happen, right? How many of those 52 are black 8s? Because that's what I want to put on the top here. So go look at your deck of cards. Got a bunch of 8s right here. In fact, I have 4 8s right here in this column, but they're not all black. 2 of them are black and 2 of them are red. So the 8 of clubs and the 8 of spades, those are the black ones, right? There's 2 black 8s right there. 2 red 8s and 2 black 8s. 4 8s total, but 2 of them are black. So if we're talking about the probability of getting a black 8, that means there is a 2 out of 52 chance of that happening. You divide top and bottom by 2, you get 1 over 26. Now that's reduced form. You take 1 divided by 26, and you round off. You should get 0.0385. I know it says 4, but look at the next number, which is a 6, makes me bump up that more. So if I'm going to 4 decimal places, we are talking 0.0385. And I'm rounding off when I do that. So that's why I put the squiggly equal sign right there. There we go. I'm going to do a couple more things sort of still about a black 8. So I'm going to kind of probably go back to this question here. But now I want to move on to odds instead of probability. So this next question said the card is selected at random from a standard deck of cards. Find the odds in favor of getting a black 8, and then odds against be our next question there. So that this is not the same thing as probability. It's a different definition. Let's go back to the notes from the class that we looked at in the beginning, and I said when we're talking about odds, it's a different definition. When we talk about odds in favor, look at the denominator. It doesn't say total number of outcomes. It says number of unfavorable outcomes. The numerator actually still says favorable outcomes. The denominator does not say total, though. It says number of unfavorable outcomes. Because one of the definitions of probability said favorable over total. Probability is favorable over total. Odds in favor is favorable over unfavorable. We never use total here. I'm never going to use the 52 on this one. When you're doing odds, you never put total outcomes anywhere. Probability has total outcomes on the bottom. Odds doesn't have total outcomes anywhere. It just basically the numerator is favorable, which means the ones that do meet what we're talking about, and the denominator is unfavorable, just the ones that don't meet what we're talking about. So this is the number that are favorable. This is the number that are unfavorable. Again, favorable means it is a black 8. There are 2 cards in the deck that are black 8s. In the bottom, I'm not going to put the total cards in the deck. I'm putting how many cards in the deck are not black 8s. There are 50 cards in the deck that would be considered unfavorable because they are not that. There are 2 black 8s. There are 50 in the deck that are not black 8s. Notice, I know there's 52 cards in the deck. Notice we never wrote 52 anywhere. We do with probability, we put 52 in the bottom because that's total. Favorable over total. Favorable over unfavorable. That's how odds and probability are not the same thing. The other thing is we don't usually leave odds as a fraction. We still reduce it. If you divide top and bottom by 2, you're going to get 1 over 25. You still reduce it like that. But we don't usually leave it as a fraction when we're talking about odds. When we're talking about odds, we usually write it either with a colon like this, or sometimes we just say 1 to 25, and you can just kind of write it out in words like that. Either of those is good. We don't usually leave it as a fraction, kind of partly to remind us that we're not talking about probability here, that we read our answer in a different way. So the odds are 1 to 25 of you getting a black 8. What that means is for every one time that you will get a black 8, there should be 25 other times that you don't. That's what we're saying. For every if you were to pick a random card out of a deck, you know, a bunch of times, for every one time that you did get a black 8, there should be 25 other times that you did not get a black 8. And the next question is very similar, but the next question says, find the odds against that card being a black 8. So the definition of odds against is really just the reciprocal of odds in favor. If you look at the definitions here, odds against just flips it around and has unfavorable on top and favorable on the bottom. Flip your fraction. I mean, it's literally going to be the opposite, you know, order of my last answer. But odds against something happening, you do unfavorable over favorable. If you were to pick a random card out of a deck, the odds against it being a black 8, you would put all the non-black 8s on top. That's unfavorable. And then all the black 8s on the bottom. That's what we mean by favorable. Remember, there are 50 cards in the deck that are not black 8s, and there are 2 that are black 8s. Unfavorable meaning it's not what we're talking about. Favorable meaning it is what we're talking about. There are 50 cards in the deck that are not black 8s. There are 2 cards in the deck that are. Again, kind of the same answer I just got on the top one, but it's just flipped, right? Now, when we reduce this, 50 divided by 2 is actually 25, exactly 25. But the thing is, we want to keep it as a fraction. And so we actually leave it as 25 over 1. It's actually a little weird. Like we would usually just write the number 25. We usually wouldn't put a 1 or keep that 1 in the bottom. But when we're talking about odds, we want to because we actually want to write our answer like this. 25 to 1. Or if you would like to just verbally say it, it's 25 to 1. The odds against you getting a black 8 is 25 to 1. That means for every 25 times that you don't get a black 8, there should be 1 time that you do. You pick a card out of a random deck a bunch of times. For every 25 times that you did not get a black 8, there should be 1 time that you did. That's what we mean by odds against. Unfavorable over favorable. Odds in favor is favorable over unfavorable. They're just flipped. Let's do another a problem kind of comparing probability with odds. And this time we'll talk about rolling 2 dice. This is a very good time for you to pause the video and try to do this page. Highly suggest you pause the video and try to answer these questions. And then come back and see how you did. So this one says 2 dice are rolled. Find the probability that the sum is less than 6. So this one's talking about probability. So probability that they added up to something less than 6. I know if I roll 2 dice, there are 36 things that can happen. And I know when I do probability, you always put the total amount of things that could happen on the bottom. That's why 36 is showing up here. The next 2 questions are not probability questions, they are odds questions. So 36 is not going to show up anywhere in part B or C. But now the question is, out of those 36, how many of them add up to a total that is less than 6? less than 6 would be, 5 or less. So you need to go to the rolling 2 dice picture and go count how many of them add up to something less than 6. I think the answer is 10. And they're all kind of going to be up here on the upper left. Because see this 5 plus 1, that adds up to exactly 6. That means this diagonal right here, they all add up to 6. But anything above and to the left of that are going to add up to something less than 6. Right? And so, like, for example, see how this 4 plus 1, that adds up to 5. So 4 plus 1 adds up to 5, 3 plus 2 adds up to 5, 2 plus 3 adds up to 5, and 1 plus 4 adds up to 5. Here's 4 so far that add up to less than 6. But keep counting all the ones also that are up and to the left, because these 3 add up to less than 6. These 2 add up to less than 6. And then this 1 on the very upper left adds up to less than 6 also. So how many add up to less than 6? I think the answer is 10. Starting right here with 4 plus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 sort of upper and to the left that are adding up to something less than 6. That means 5 or less. So there's a 10 out of 36 chance that if you roll 2 dice, they're going to add up to something less than 6. You take 10 and 36 and divide them both by 2, or make your calculator reduce like I kind of talked about earlier, you get 5 over 18. If you put 5 over 18 in your calculator and round off, 2778 is what you should get. If you try to turn it to a decimal, it will be 277. There's a bunch of sevens, but it's going to bump up to an 8 if you're rounding off. Just over 27, almost 28% of the time, we would expect for the total to add up to something less than 6 if we rolled a pair of dice. And the odds in favor of the sum being less than 6. So we start as a fraction. We don't leave it as a fraction, but we start as a fraction. And this time, remember, odds in favor does not use total anywhere. 36 is not going to show up anywhere. It's just going to be like yes versus no, or favorable over unfavorable. So actually the 10 is still going to go up on top here. It's the same 10 we're talking about right there. There's 10 of them that add up to less than 6. But instead of putting 36 on the bottom, which is the total number of outcomes, we want to put all the ones that don't meet the requirement that we're talking about. The bottom is unfavorable here. Unfavorable means all of them that don't add up to something less than 6. So if 10 of them do add up to something less than 6, there are 26 other ones that do not. Let me say that again. Remember, we pointed out these 10 up here, kind of showing you those 10 with my arrow. I think you can see that. There's 10 of them sort of on the upper left that do add up to something less than 6, but that means all the rest of them, down and to the right, all the rest of them are not adding up to less than 6, and there should be 26 of them left, right? I also know there's 26 of them left because remember I said I never really used 36, but it is true that those two need to add up to 36. That one is true. Whatever your total is that you're using for probability, when you do odds, those two numbers need to still add up to the total. Okay, so that's something to kind of check. Notice that 10 plus 26 does equal that 36, but we never write 36 is what I'm saying. We still reduce, divide them both by 2. 5 over 13, but we don't leave it like that because that kind of looks like a probability and we're not doing a probability. So the best answer, in my opinion, would be to write it like this. The odds are 5 to 13. I'm also okay. I'm putting the quotes because like that's how you would like say that, but I'm also okay if you want to write that instead. But we would say 5 to 13. The odds are 5 to 13 that if you rolled 2 dice, the sum would be less than 6. Now for the next question, part C, where we do odds against, it's just going to be the same answer we got in part B, but it's going to be flipped. The odds against the sum being less than 6. We're just going to flip it. We're going to put unfavorable on top and favorable on the bottom. We're going to put the 26 that did not add up to something less than 6 over the 10 that did add up to something less than 6. So that's the difference. So odds in favorable has favorable on top, unfavorable on the bottom. Odds against has unfavorable on top, favorable on the bottom. Reduce this just like normal, divide top and bottom by 2. This time we get 13 over 5. Now it's an improper fraction. Some of your calculators are going to show improper fractions in a kind of strange way. Some of your calculators are going to show improper fractions in a weird way. They're going to show it as a mixed number actually, but it's going to look weird on your calculator. If you get to that point where you did like 26 over 10 like as a fraction and then you try to make it reduce it, it probably says something like 2 3/5 or something like that, because that's what that would be as a mixed number. But I think if you press this is going to be definitely different on every calculator. I think if you press second ABC equals at that point, it should switch it to a improper fraction that looks like that. Let me look at the calculators again here. So if you get to that point, what I'm talking about was if you did if you were trying to take 26 over 10 and you're trying to turn it into 13 over 5, but instead it has like 2 3/5, or it has a 2 and a 3 and a 5. That's the mixed number 2 3/5. If you're using this calculator, I believe at that point you would press second ABC equals, and then it should turn it to 13 over 5. If you're using this calculator, looks like it's above this button right here. See, that kind of looks like a mixed number and then back to a fraction. So I think if you're using this calculator, you could press second and then this button and then probably equals or enter. It's the button right next to your fraction button. So you get to that point and then you press second, this button, and then equals. And then on this one, not totally sure on this one off the top of my head. Might be above here. Let me see if I can zoom in a little, see more what that says. Yeah, it's probably above this SD button. So you probably have to press Shift, SD, and then equals. Shift, SD equals. By the way, that SD probably converts between fraction and decimal also. So without pressing Shift, if you use the SD button, I think that's going to convert between fraction and decimal for you. On this calculator, I think I saw something that did that also. See how it says FD on the top? That means fraction decimal. So if you ever need to convert between a fraction or a decimal, you could go second and then that button, then equals, and it'll probably change your fraction form to your decimal form or vice versa. See if there's something like that on this one. Yeah, there's a FD button right there above PRB, above the probability. Second PRB equals. That would convert for you between a fraction and a decimal. Okay, so anyways, back to the question we were working on. 13 to 5 is my answer. If you were to roll 2 dice, the odds against them adding up to less than 6 is 13 to 5. That means for every 13 times that it does not happen, there should be 5 times that it does happen. It's unfavorable over favorable. Unfavorable over favorable. Odds against. I think there's a pretty good picture here in your notes talking about the difference between odds and probability. So think of the blue ones here as favorable and the yellow as unfavorable. If you were doing like odds in favor, it would be favorable over unfavorable. But if you're doing probability, it would be favorable over total. So probability includes everything on the bottom and then only favorable on top. Odds, at least this is odds in favor, shows favorable over unfavorable. So that picture might help some of you if you're a visual learner. I think we have just one question remaining here. The LA Lakers have a 44% chance of winning the next NBA championship. Find the odds in favor of the LA Lakers winning the next NBA championship. Well, I mean, what do we mean by 44%? I mean, that's a probability. That's not we're trying to find the odds in favor, but we're given the probability. Remember, probability can be written either as a fraction, a decimal, or a percent. So we're just given the percent version of the probability. What does percent mean? Percent means out of 100. So one way, if we wanted to write it as a fraction, we could write it like that. It's not really a reduced fraction, but that is a fraction version, non-reduced. But that's not what we're being asked. That's the answer. Like that's a probability type answer. We're asking for odds in favor. Odds in favor means the times they win over the times they don't win. Championship. Well, they win 44 times out of 100. Like that kind of means like if we were able to like replay that season many, many times, say we replayed that season over and over again 100 times, we would expect the Lakers to win 44 of them, of the championships. But what we want to put down here is not 44 over 100. It's 44. It's winning over not winning. This is winning over total. This is winning over not winning. If we would expect them to win 44 out of every 100 times, how many would we expect them to lose? So this is going to require us to actually do like a subtraction here. 100 minus 44 is actually 56. Notice that those two add up to 100. I never actually use 100 here. Okay. So again, this is a probability answer up here. We're saying if we replayed that season 100 times, we would expect the Lakers would win 44 of the championships. But that means they would lose the rest. So what is the rest? We'll subtract you get 56. That means they would win 44 times and they would lose the other 56. That's what we think would happen. That's what we mean by odds in favor. So this is a problem by where we're given the probability and we're sort of converting it into odds, at least odds in favor. We still need to reduce. If you divide top and bottom by 4, you'll get 11 over 14. And that is not my final answer, because when we are doing odds, we want to write it like that or like that. This is the sort of thing you need to be aware of if you are like gambling. If you plan to get addicted to sports gambling, you go to Vegas or something like that, you go where you're making bets. They don't usually tell you anything about probability. They usually are talking about odds. So be careful whether you're reading odds in favor or odds against. But you'll usually see something like this when you're about to place your bet. It's just kind of telling you the likelihood. This particular thing is saying for every 11 times that we think they will win the championship, there will be 14 other times that they won't. That's what we're saying here. For every 11, if we replayed this season somehow, you know, in the alternate universes 100 times, we think for every 11 times the Lakers would win the championship, there would be 14 times that they would not. But be careful if you are going to make a sports bet, be careful whether you are reading the information they're telling you. Be careful if that's odds in favor or odds against. The one we just did right here is odds in favor. Okay, that wraps it up for today. Thank you for watching.